Okay, so let's look at example 3.1. Remember in the previous video we saw that there is something called average acceleration, which is your change in velocity over change in time. So this example asks, or states first, a car's velocity increases from 0 to 5 in 1 second, and then from 5 to 10 meters per second in the next 2. So let's draw this. Let's draw it. Guys, always try to draw things. So what is this? This is a velocity time curve, and in the first, from over 1 second, it goes from 0 to 5 meters per second. So there is my data point. So it goes from 0 to 5. Okay, and then if that's 2 and that's 3, let's turn that off. If that's 2 and that's 3, then at 3 seconds, let's just try to draw a line up here, we have 10 meters per second. So it then moves to there. Okay, so that is our velocity time curve. What is the x component of its average acceleration? Okay, so we know average acceleration is v final minus v initial over delta t. So what is the average acceleration during the first second? What is it here? What's the final velocity? It's 5. What's the initial velocity? It's 0. And what's the change in time? It's 1. So we have 5 meters per second squared. Let's just insert some more white space here. Okay. Then the next question is during the last 2 seconds. So what's the average acceleration over the last 2 seconds? Well, average acceleration is going to be the final velocity 10 minus the initial velocity 5 over the final time, which is 3, minus the initial time, which is 1. So that's 5 over 2, which is 2.5 meters per second squared. Then the last one is during the entire 3 seconds. So the final velocity is 10, initial velocity is 0, and the entire time is 3. So we will have 3.3 meters per second squared. Okay, this is just a gentle introduction. Average velocity is your final velocity minus initial over your change in time.